All right, but section 7.3, somebody asked how many more sections do we have? We have 7.3, 7.4, 7.5, and 7.6. Woohoo! You know me, I'll combine some of those together so they're not quite so crazy. But for today, we're going to actually write and evaluate logarithmic expressions. So you're going to actually kind of see what a log does. Does anybody remember what I told you previously? What do we use them for? What do we use logs for? They could be. Not that kind of log. You guys remember? I mentioned it yesterday. We use them to solve what? Riley, you're mouthing it back there. What was it? Exponents. Yes, it's for solving exponents. All right. So first thing that we need to look at, though, is like, what do they look like? How are they written? And most importantly, because it's painful to me when you guys say things incorrectly, how do you read them? Do you remember what happened in here when you guys were reading answers like the cubed root of something? Like, that was painful to hear you guys try to read those. All right, so first things first, let's look at the logs. All right, so here's a very basic log that's written with all variables in it, which I know that makes it harder sometimes. But this version and this version, they mean the same thing. So if I gave you something and I was asking you to solve for x, right? I think the example I gave yesterday was like 2 to what power is like 6,004? Well, you'd have no idea, right? Other than guessing and checking and trying to figure it out. So we can take something like this where I'm trying to solve for an exponent and I can rewrite it into this form with the log, right? Today we're going to look very basic, like you're going to do them without a calculator today, just to get some basics on how they work, and then we're going to move tomorrow into actually using your calculator and doing some computations with them, okay? But the main goal for today is to be able to switch between the two forms, right? Just with like we did with radicals and then exponential form, we could switch back and forth. We spent a whole day just practicing that. Same idea for this as well. We're going to practice going back and forth. It's a very technical term I've come up with. You guys ready for this? It's called loopy swoopy. You guys got that? It is loopy swoopy. It's very technical. Loopy swoopy. Everybody got that? Loopy sloopy. So it helps me remember this. And I'll be honest, it's still in my mind when I do these. I'm like loopy swoopy every time I do them. Okay. So the way this works, if I look kind of back and forth between my two forms here, to rewrite these, let's say it started in log form and I wanted to switch it back. You start with the base. This is read log base b of y equals x. So log base b of y equals x. So you start with the base number, you take it around to the x, and then you swoop it back over to the number next to it. Loopy swoopy. Hang with me. I know this is very different from anything you've ever seen. So if you look at what's happened over here, it's b to the x power equals y. B to the x power equals y. It's my loopy swoopy of trying to get it back. Okay? Same idea if I'm going from here back to this version, right? I would write log, because I know I'm switching it back to a log, loopy swoopy again. The b, then the y, then the x. It's the order in which I write them. It'd be log base b of y equals x. That's exactly where I came from. So loopy swoopy, and it'll make much more sense when I start throwing actual numbers at you. Okay? Loopy swoopy. Extra credit for anybody who comes up with a song for loopy swoopy. Yeah, absolutely. Yes, I would love to hear it. Yeah. Oh, I think I actually am saying swoopy, aren't I? Loopy swoopy. Yeah, you're right. Swoopy. Change that to a W. Loopy swoopy. I think it is what I always say. Sorry. My own technical term. I messed it up. Sorry. Loopy swoopy. Let's look at some actual numbers, though. I think it'll make more sense to you how this works. Okay? So, again, just trying to practice going between one form and the other. So starting with log form, loopy swoopy, the base number 5 squared equals 25. See how it got written? 5 squared equals 25. Agree? You guys know 5 squared is 25. So we got to practice with numbers that make sense to us first. So how would you write the next one? Log base 4 of 64 equals 3. Perfect. It'd be 4 cubed equals 64. Again, loopy swoopy. 4 cubed equals 64. It's always the same loopy swoopy every single time. So how about the next one? Perfect. So 7 to the negative 2 equals 1 over 49. Is that true? What's a negative exponent do to this? It's going to move it to the bottom, and then it would be 7 squared, which is 49. Now, kind of looking into the future, what's coming for this, you guys? I'm going to have you solve some of these on your own without a calculator. We're going to get to that eventually. But you're going to have to be able to kind of think in your mind, if I start with this, you're like, okay, 7 to some power equals 1 over 49. You're like, okay, I started with a regular number and it moved it to the bottom of the fraction. What always moves it to the bottom? Negative. So in your mind, you're like, okay, it's going to have to be negative because it moved, and then what do I have to do with it? Okay, so you got to kind of start thinking of these things. All right, log base 32 of 4 equals 2/5. 32 to the 2/5 equals 4. 32 to the 2/5 equals 4. Stop and think for a minute. What does 2/5 for an exponent, what does that mean? Here we go, trying to read those roots again, aren't we? Oh, there she said it. The 5th root of 32 squared. That wasn't as painful. That's good. Yeah, and could you type that in your calculator, 5th root of 32 squared? Yeah, we could figure that out. And it indeed is 4. Okay? Adrian, last one. How would you rewrite that one? Can you loopy swoopy? So 36, you said half. Where's the half? 2 to the half. Good. Equals 6. What's half power mean? Squared? Square root. Good. That means the square root of 36, which is 6. So how are we feeling going from log to exponential? See the loopy swoopy? Makes sense. Yeah, you look like you need some sleep. All right, can we go the other direction? For whatever reason, people usually struggle more going this way. The big thing is when you're doing the loopy swoopy on this one, it's the order that you're writing the numbers. From left to right, it's the order that you're writing them. Let me show you. Right, so if I loopy swoopy, it's 5 and then 125 and then the 3. So log base 5 of 25 and then the 3. So from left to right, it's the order in which I'm writing those numbers. The first one is the base, because that's the first number you would write. Then it's the 125, and then equals 3. So it's the order in which those numbers get written. Yes? That was a big yawn.
Yeah, so like, so you start with the most left one, go use the next one, and then go back to whatever one.
The exponent.
So just don't reuse it.
Correct. Do not reuse your toilet paper. All right. So again, if I'm switching to log form, obviously the first thing I should write is log. Does anybody know why I write an L like that and not a straight log? It might look like an I or it looks like a 1, and then it looks like I wrote 10G versus log. So that's why I write a cursive L, so it doesn't look like 10G. Me too. All right, so if I'm doing this, it's log, what's my base? 81. And then a 3 equals 1/4. If you're really good with loopy swoopy from log working it back, could you check your answer? It makes sense. Does it work? If I loopy swoopy again, 81 to the 1/4 equals 3. That's exactly what I had. So if you're really good one direction, maybe kind of do what you can and then be like, does it work? No, it doesn't. Okay, go back. Fix it again. Because this is the way that most students, if you're going to struggle, it's going to be going from this direction. So from here, it's going to be log, what's my base? Of what number? 1/4. 36 equals -2. This is your thing, Adrian. All right, Tara. Log base.
Hold on, I was just working on that one.
Good. Of what number? Let her do it.
I'm gonna write it.
Okay. Log base 7 of
Or 1.
1. Good, equals 0. Yep, so your 7's the first number, then I'm writing the 1, then it equals the 0. Anything to the 0 power equals 1. Remember, poof, Dakota, I made you disappear when we first talked about this, remember? Anything to the 0 power equals 1. Dakota to the 0 power equals, poof, bye-bye, Dakota. There's just a 1 left in your spot. I made you disappear. That's funny. He's been my example all year long, right? Which part are you confused on, hon? Anything to the 0 power equals 1?
Yeah, but so you have 7, and then one the big number, or
Are you confused on the way this is written or the log one? Okay, so remember this loopy soupy tells me the order in which I'm writing the number. So the 7 is the base, then the 1, and then back around to the 0 equals 0. That top one's always what it equals.
What I was trying to figure out is how is 7.
So then 7 to the 0 power equals 1.
Well, I know that, but like, how does that equal 0?
Because this is asking 7 to what power equals 1. That's what that would be asking you.
It's not necessarily an actual.
No. Right. No, that's a great question, though. Guys, I don't know if you heard the question that Dakota just asked. Like, she was stuck on, how does this equal 0? Like, I didn't understand how that could possibly equal 0 for a value, right? So you got to stop thinking this equals this. You got to think, what does it mean? Like, if I would ask you log base 4 of 1, if I just gave you that and I said simplify, your brain has to see that and go, 4 to what power equals 1? It's 0. 4 to the 0 power equals 1. And that's how you're going to see things. Like you might see log of 3 and then a 9. What's that? It's 2. 3 to what power equals 9? It'd be 3 squared equals 9. Yeah, you got to start training your brain to think slightly different through this. And this is like, you guys have never seen stuff like this. Jonas, last one up here. It'd be log base.
36.
Base 9 of equals. Good. Again, loopy swoopy. 9, then the 27, and then the equals 3/2. Yes. Good question. All right, the question was, how do we type the logs in there? Yeah, you right now, if you're trying to type these in, it ain't gonna work. Right, and hold that thought. I am coming to that. I promise you we will get there. So hold that thought for a minute. All right, so guys, let's just practice evaluating. Okay? Rewriting them from the different forms. So let's practice evaluating. Again, this is one of the things we need to get used to, changing our thinking on these. So this one right here is asking you, and sometimes it helps to rewrite it in the other form so you can visually see what it's asking. It's saying 2 to what power equals 32. That's what it's asking. And what is it? It'd be 5, yeah. But sometimes it helps to rewrite it in exponential form so you can kind of see what it's asking. So this one's asking 3 to what power equals 1? 0. Anything to the 0 power equals 1. So this one is asking me 4 to what power equals 2? It would be half. Why is it half? No. It's an exponent. The square root. That's what I was looking for. Yeah, because the square root of 4 is 2. You got to be thinking exponents every time, not just multiplying. All right. And then 10 to what power equals 1 over 100? Ooh, you guys are fast on that one. Yeah, look at this. I know if it's here and it got moved to the bottom, it had to be negative. Then how do we make a 10 100? You square it. So 10 to the negative 2. Oh, I was impressed. You guys grabbed that really fast. All right, questions here? Are we doing okay? Some of us yes, some of us no. What are you typing in? It's going to give you, then hit your math button and then change it to a fraction. We can't yet. Hold that thought. Did you figure it out? Guys, real quick, do me a favor. In your calculator, since we're talking about, let's talk about it right here. I want you guys to type in log. Hit your log button. Hit your log button, and then type in 1 over 100. Type it in as a fraction or put it in parentheses, either way, and hit equals. Okay, hold on. I'm going to explain why they all didn't work, okay? I'll explain in just a minute. Yeah, if you typed in this one, log of 1 over 100, it gave you negative 2. Now, if you typed in log of 2, did it give you half? Try it. Type in log of 2. Does it give you half? Mm-mm. It should. Did you type it in as a fraction or? Let me see what you got. That's an E, hun. We want log. It's a button that actually says log. All right, guys, the reason the calculator worked on this one, but not on this one, is because your calculator by default has a base of 10. This one has a base of 10, so it worked. This one does not. It didn't work. Now, as this class continues, probably tomorrow or the next day, I will show you another option to get your calculator to do what you want. Okay? But as of today, I want you to be able to think through them on your own in your head, like getting used to the changing of them. Okay? You are trying to figure out what exponent does that make that true.
So it's just
Yeah. 10 to what power gave us 1 over 100? Well, 10 to the negative 2. The negative pushes it down. 10 squared is 100. All right. So let's try a couple more. So if I just give you log base 4 of 64, somebody tell me, what is it asking? Because again, we got to get used to thinking what this actually means. Good. So again, it's that loopy soupy. 4 to what number equals 64? And it is 3. All right, 4 cubed. 4 times 4 times 4 is your 64. All right, log base 5 of 0.2. Oops. So what is that asking you? So it'd be 5 to what exponent equals 0.2? Now, let's stop for a minute. Let's make our life a little easier, okay? Forget the calculators for a minute. Some of you are so calculator dependent. Just hang tight. What's 0.2? How would you read that? I heard a lot of different things. It'd be 2 tenths, right? That's the tenths place. So stop for a minute and think, if I had 2 tenths, how else would you, bless you, how else would you write 2 tenths? 1/5. This makes this so much easier. So really it's asking me 5 to what power? Yes. So if you have the decimal, rewrite it as a fraction. We understand fractions a lot better. You guys have hated me all semester for making you write everything in a fraction. but it paid off here, right? The negative's going to push that to the bottom. Yes. You can just write the answer if you understand it. Absolutely. I just want to make sure everybody knows where it's all coming from. All right. Next one. Log base 1/5 equals 125. First, what is it asking me? Okay, so let's stop and think for a minute. It started with 1/5, but it's no longer a fraction. It has to have a negative because it moved it back up. So I know it's negative. And then 5 to what power is 125? It'd be 3. Mm-hmm. You can't. Nope. We got to think through it. You're going to have to try to play catch up then. All right. Are we okay? Now, Adrian, I heard you say 25. Adrian, in your mind, you were multiplying 5 times 25 to get 125. Okay, we got to switch our mind into exponents. I know that's hard. All right. The next one. You missed a very technical term, John. The term is loopy swoopy. Got that? Loopy swoopy. All right, so this is asking me 36 to what power equals 6? It'd be half, because that would be the square root of 36, which is 6. What if it was like the cubed root? What would you write? Like, it'd be 1/3. Yeah, it'd be 1/3. We okay? See, this is where I was going to talk about the calculator. We already did. We already did. The calculator, it is referred to as a common log. So we have like unspoken numbers, right? We talk about the unspoken 1. We have an unspoken 2 in square roots. We have an unspoken 10. Isn't math fun? All these unspoken things. So if you see just log, like log of 10, this is saying log base 10. If you don't see a base number, it is implied that it is a 10. It's an unspoken. It's considered a common log. If that happens, your calculator will do them. Yay! Right? So what is this? 10 to what power equals 10? It's 1. Yeah, it's 1. Now, the reason we like to deal with things is because everything nice and pretty in math? Heck no. Most times it's not nice and pretty. So if I'm looking here, oh, these are the nice ones still. My next slides are not so pretty. Sorry. A few more nice ones. If I don't see a base, what is it considered? 10. So this is 10 to what power equals 100? 10 to what power equals 100? And it is 2. 10 squared is 100. Did you get that one right? All right, again, unspoken base, so we know it's a 10. Just like with the unspoken 2's and our square roots, write them in. It's more helpful to see them. 10 to what power? Man, you guys are like getting these faster than I can even write them down. How did you know it was negative? Yeah, it moved it. So it had to be negative, and then 10 to what power makes it 100? 2, so it's got to be negative 2. This one again, write in those unspoken numbers. 10 to what number equals 1? Good. Anything to the 0 power equals 1. Unspoken 10. 10 to what power? 10 to what power equals? That's 1/10. Remember, we don't like decimals. It makes more sense to write that as 1/10. See how much easier it is to see that when you write that as a fraction? You're like, oh yeah, move down. It's negative. I mean, if you can use the decimal, that's fine. Now, granted, could you have typed these in your calculator? That's fine. Totally fine. Mm-hmm. Yeah. Yep, because it's going to move it. Dakota? We will. We're getting there. All right. So let's go ahead and practice the calculator a minute, and let's talk about why we're going to go to the calculator. Because what's my base number? 10. So this is saying 10 to what number equals 1/3? What do we know for sure it's going to have to be? It's got to be negative because it's going to be on the bottom. Can I turn 10 into a 3 with an exponent? Is it a pretty one? No, it's not pretty. So grab your calculator. This is why we have logs in the first place, okay? It's because not all of them are pretty, so we need to figure out how to get those numbers if it's not a pretty one. And the calculator can do that for you. So type in log of 1/3. Riley? If it's a different base, I will teach you how to do that. I believe it shows up tomorrow's notes. We're baby stepping. All right, so we should, whoa, didn't mean for that to move. All right, so we should have gotten negative 0.4771213, yada, yada, yada. All right, yeah. But guys, stop and think for a minute. Take a minute. If I would do 10 and raise it to that power, would you get 1/3? And you do. If you can try it if you don't believe me. Type it in your calculator. You can type it in and it will give you that. Now, granted, if you round that off, it may vary slightly because you rounded it. But yeah, it should be. So log of 2.5, 10 to some power equals 2.5. We don't know that. Give me like 4 or 5. I won't be overly particular as long as I can see that you had it. So there's roughly the next one. How are we doing back there? We okay? Yeah, Taylor. You wouldn't need the zeros on the end. Yeah, it's fine. Guys, as far as if I ask you this, how many decimals do I want? Give me like 4 or 5. It's fine. Just so I can see that you know that it didn't just end. Uh-oh. What do you mean you got a domain error? What is this asking me? Let's start there. What's the base? So it's saying 10 to what number equals -2? Can you raise a positive 10 to some exponent and make it negative? If I raise it to the half, that means I'm taking the square root of it. Is that going to make it negative? -2 is not the same as a half. Can I raise a positive number to some exponent and it suddenly turn negative? Because an exponent means like 10 squared means 10 times 10. You can't do this, right? When you type this in, you got an error. Oh my goodness, that shot right off my page, right? This is undefined, no solution. You can't do it. The fraction, or making a negative for your answer, would move it in a fraction. This is asking what exponent's going to turn a positive number negative. That's not going to happen. All right. You guys ready for bingo race?